In this video, we're going to describe how you make particular types of triangles. Specifically, in this one, we're going to focus on how do you make an equilateral triangle, as well as how do you make an isosceles triangle. Okay? Do recall that an equilateral is a special type of isosceles triangle, so although it is very unlikely that you would automatically just create one without trying. Okay. We will not be looking at acute or obtuse. The descriptions on how to make those are also directly in the text. Okay. So in order to do this, we're going to just start with a straight line, saying that or a part of that from, say, point A to point B is an equilateral triangle. Okay, so this is just one side of that triangle. We're going to use our compass because we know that the other two sides are going to have the same measure as A and B. Okay? And we're just going to sweep out a circle, okay, or at least part of a circle, that makes that same distance. So everywhere along this circular path, of course, is the same distance as it is to B from A. We're going to do the same circle this time from starting at B. Okay, it's going to run through A, and now we have one point, and only one point, that is actually the same distance away from A as it is to B. Okay? If we were to continue to draw the circle all the way around, there would actually be a second point way down here that would be the same distance away. So you could make two equilateral triangles if you really wanted. In general, we only care about one. Okay? So if this is point C, our equilateral triangle then is from point A to point C, and from point C to point B. Okay? Now, how do we verify this? Well, remember, our compass stores our length. We can actually verify this by having our compass at point C and showing that it guaranteed intersects both A and B when we sweep out a circle. Okay? So we're actually going to do that and show that, yeah, it runs through A, and it also runs through B. Okay? So each of these is the radius of the same size circle. Therefore, all three sides are congruent. Okay? By definition, then, this must be an equilateral triangle. Okay? We're now interested in drawing just an isosceles triangle, a generic isosceles triangle. Okay? In order to do this, we again start with our straight line, go across, okay, and we start with some point just offset. Okay? Point A. All we need to do is guarantee that two sides are the same length. So two sides can be radii of the same circle. Just happens to cross this other line that we have. So we take our compass, make sure it's wide enough to cross the line, okay? And it's guaranteed to cross not once, but twice. Okay? In this way, we have 2 points of intersection, points B and C. Okay? And they are, because they are radii, the same length away from A, which guarantees that it is an isosceles triangle. Okay? Now, when you do this, since we stored the length here, this is the length of one side, the other length is here. Notice we can say automatically that there is some extra distance here, so we know that it is not an equilateral triangle as such. Okay? So the chances of you just happening to get an equilateral triangle from this construction are actually very, very small. Okay? So what are the important properties of this? These two lengths, being radii of the same circle, are equal. By our isosceles theorems, that means that these two angles are also automatically congruent.